All right, good afternoon, evening, morning, whatever may be the case. In my case, it's really early in the morning. It's about 4:50 a.m. at the moment. So it's as you can see, it's nice. The sun is not quite out yet. So hopefully by the time I finish the talk, the sun will be out and you'll be able to see a bit more sunlight today. So welcome. Really happy to have you here. Wherever you are, hopefully we can get started and make good use of the next 15 minutes or so. So my name is REZA RAHMAN. At my day job, I'm Principal Program Manager for Java on Azure. I'm happy to present this talk to you today. I'm going to start sharing my screen and go from there and explain a bit about what this next 50 minutes is about and what you can hope to get out of it and how I hope to do what I'm going to do. So let's start sharing. And you're going to see a psychedelic screen just for a moment. Don't worry too much about it. But I will flip to the real stuff here in a moment. Let me just click hide on this little guy for a little bit and move here. All right. So what is this talk about? The talk is titled Effective Kubernetes for Jakarta EE and MicroProfile Developers. It's quite a mouthful, but I will explain what the intent here is. So you can use, like all major platforms, using Jakarta EE and MicroProfile and Java EE technologies. You can definitely use these with Docker and Kubernetes. However, there are some trade-offs to think about. They're not too different from the other mainstream platforms, and in fact, Java-based platforms in general. They have a lot, and these are fairly common concerns, common things that you need to know about. Some things are, in fact, specific to Jakarta EE and MicroProfile, primarily because the Jakarta EE and MicroProfile communities have done a pretty good job aligning themselves with cloud-native technologies like Docker and Kubernetes. But other than that, I would say even if you're not necessarily using Jakarta EE and MicroProfile, you can probably expect to reuse about 60 to 70% of the stock. And in fact, even if you're not using a Java platform, you can probably take away about 30 to 40% of the stock, because a lot of these concerns are actually relatively common. So this material that you see in front of me, by the way, there's no slides for this talk whatsoever. Primarily in this talk, I will be doing live demos and sort of explaining things as I do live demos. However, getting back to the material, this material actually is a workshop. I presented this as a workshop, but it is also intended to be a sort of self-service workshop, a workshop that you can do on your own. If you do that, and if you run through this material end to end, it'll take you about 8 hours plus or minus to do that. So obviously we don't have 8 hours. We just have about 50 minutes, as I said. So what I will aim to do is basically introduce what this material is in GitHub, available to everyone, and take you through some representative portions by cheating a little bit. By cheating, what I mean by that is I've done some parts of the workshop a bit ahead of time, just so we can get through this in a 40, 50 minute time frame. So that's what I'll be doing. I'll basically be going through this material, mostly in basically live coding mode, and telling you a little bit about what this material is. The other thing I'd say is I probably will take up the 40-50 minutes doing live coding, but that need not be the case. You can stop me and ask me questions, so feel free to do that at any point in time. I don't know how well you'll be able to do that. So feel free to do that either through the chat. I will check the chat intermittently here and there. Alternatively, feel free to use this questions control. There is this one control that you can use, and you can post questions there. So really, it's up to you. Either way is fine. Don't hold back questions until the end. Just simply ask them, and that way we'll be able to make best use of the of the time. If I need to stop and answer your questions, I'm happy to do that. If I don't, I can just keep rolling ahead. Okay, so this is what this is the material again. So there's several sections in the material, and I do recommend that you go through these material in order. I think it makes a lot more sense in order. I won't be maintaining strict order per se in this particular talk, just in the interest of time. But when you go through it, I recommend you go through it in order. So the first and foremost is we'll be using a simple Jakarta EE application to introduce the capabilities. So this is really nothing much more than what you would do on premise. It's basically a simple Java EE Jakarta E8 application. I happen to be using Open Liberty as an example, and JDK11 Eclipse IDE as an example. But honestly, you could use any Maven capable IDE. Ultimately, this is just a simple Maven project. And you can use any Jakarta E8 compatible runtime. I listed a few here. You could use Open Liberty, Wildfly, JavaScript, Pyara, whatever you so wish. It's relatively straightforward to switch it around. And in fact, all of that what I'll talk about in terms of alignment with Kubernetes, more or less is applicable to all of these app servers. And I'll also be using Azure as an example. But again, a lot of it is very, very applicable to whatever Kubernetes platform you may be using, either on Amazon or perhaps even on-premise or what have you, or Google, of course. Google's has an excellent Kubernetes engine as well. So this first folder. It's really very similar to what you would do on your own laptop. It has very little to do with the cloud, and I will go through that in a moment. But it's an important foundational step for you to go through that and see how the basic application looks like, and also understand how your, if you will, your day-to-day normal development is going to look like. Then where we will move into is taking this application and moving it to a Kubernetes platform using nothing much more than Kubernetes platforms. So these are very simple things that I'll go through in a moment. These are the Kubernetes primitives are things like deployments and services and ingress controllers and the like. And this should be sort of your first step of getting into Kubernetes. That's what you would typically do. And in our example, I will actually show you a clustered example. So it's assuming a stateful application, an application that maintains state, and how you would do that, how you would move such an application into a Kubernetes-based deployment using some of the Jakarta EE paradigms, and show you how things differ and what stays the same when you do that. So how do you do things like app server administration, clustering, auto scaling, load balancing, auto discovery, and the like, right? How does it differ in a Kubernetes-based deployment? That's what you'll see. So this is a part of the demo that I will run through, part of the workshop that I will run through in live coding. Now, when you're moving into Kubernetes, actually you don't use the app server administration capabilities as much anymore, because Kubernetes comes with much richer ways of doing observability and monitoring. So in particular, there's things like liveness and readiness probes to better integrate the application state and the app server state with Kubernetes, and also much better facilities for doing things like observability and monitoring. So these popular technologies on Kubernetes are things like Prometheus and Grafana. So in the monitoring folder, I basically demonstrate how you set all that up and how you get something like Open Liberty working with Prometheus and Grafana. And actually, Open Liberty has very close integration with those technologies. In fact, majority of application servers too have such kind of integrations in one shape or form or the other. So the monitoring folder will show you how to do that. I will not go through that because simply because there is not enough time for me to do that. Now, above and beyond that, aside from just using just your very basic Kubernetes primitives, most application servers actually go beyond that and make use of Kubernetes capabilities like operators, and I'll explain what operators are. I'll show an operator in action. Or in case of some application servers using Helm charts. and they're relatively related concepts. These are both are higher level constructs than what Kubernetes primitives are. They all build upon Kubernetes primitives in one shape or form or the other. In this case, I will show you how to use app servers with operators, which is actually probably the more common mechanism. Most app servers do have one kind of operator or the other that allows you to deploy to Kubernetes in a slightly more application server or Jakarta EE native way. So it's closer integration between Kubernetes as a platform and the Jakarta EE runtime, and you'll see what I mean by that when I go through the examples. So the operators example is something that I intend to show you, and that's in the operators folder. And finally, one of the main reasons of doing all of this, doing the cloud native technologies and going the containerization route, is actually to do better CI/CD. But the CI/CD in the Kubernetes world looks a little bit different than it does in your normal on-premise environment or just using, let's say, Maven. So in the DevOps folder, I show you how to do that. The technology in use is GitHub Actions. I think it's relatively popular. But once you take a look at what is going on there, I think it's relatively easy to also apply it to other CI/CD platforms like Jenkins. Okay, so I won't go through that, but you can take a look at it. So that's about the sum total of what the flow is of the workshop and all the materials. I hope you will take a look at it later on yourself. I have posted it already in the chat, so feel free to look in the chat to understand where this GitHub repo is. But in short, it's in my own GitHub repo. You can always, if you don't remember it, you can always browse to my GitHub repo and find it. It's fairly obvious where it is. It's literally called Jakarta EE Kubernetes, so not very difficult to find. So without further ado, let me move forward and do remember again, I'm moving a little bit fast. So if you have any questions, please just ask them. I will stop at one point and answer any questions you might have. In fact, let me just do that right now. Okay, all good. I don't see any questions as of yet, so I'll just keep moving in the interest of time. Okay, so as I said, one of the ways I'm going through this material today is I'm cheating a little bit by having done a lot of stuff beforehand, okay? So right now I have a full-fledged environment setup. So these are all the environment setup requirements. I have JTK 11 installed on my machine already. I have the Eclipse Enterprise for enterprise Java developers ready and installed and ready to go. I have Docker installed in the OS. Technically, you do not need to use Docker for this particular portion, but since the talk is on Kubernetes, it's helpful to, there's certain advantages to using Docker. So I'm using Docker even for the local setup. And then you will need this repository. So you can download this repository onto your file system in some way. So the first step is that this is a database-driven application, so we will need a database. The database I chose to use in this case, somewhat randomly, is Postgres. So I could have installed the Postgres database natively on my desktop, but yeah, I didn't need to do that. And in fact, this is one of the advantages of Docker, is that you can use sort of these, try to use these things, whatever it is that you're trying out, without actually installing it on your machine locally. You can just simply run it as a Docker image. And I'll show you what I mean by that, because that's what I'll be doing for the database in my case. So here's the command to run that. I won't make the assumption that you are an expert in Docker and Kubernetes, although I won't be able to explain the basics of Docker and Kubernetes. I will show you the basic primitives of how to get all these things running and explain the syntax in a very basic way. So here's the syntax to run the Docker image. If you haven't seen Docker before, this is simply the Docker daemon. I'm referencing the Docker runtime, which is running on my local machine. Docker run means run a Docker image. IT means interactive, so run this in the foreground. You can run it in the background if you so wish. RM simply means when I shut down this image, don't cache it. Get rid of this. Get rid of the image that I'm about to run. And then there's these -e is environment variables that you're setting. In this case, I need to set one environment variable. I can give it a name. So -- name is just giving the image a name in case something happens and I lose lose my focus on the image, I can always go reference this image later, running image later on by this time. So that's the reason for this name here. Dash P is interesting. So one of the most complicated things you need to understand in Docker and Kubernetes is networking. So when I am running these Docker images, it is actually running in its own subnet within my own machine, or in its own network. So that network, think of it as something that is within a firewall. So I will not be able to access it unless I do something specific. So that's why you need this dash p parameter. And basically this dash p parameter is saying, please expose a particular port within that subnet. So I'm exposing port 5432, which is where this database will be running. So the Postgres database will be listening on port 5432. And that is basically, this dash p parameter is basically allowing me access to that port. So dash V is also worth explaining. This is mounting a volume. So if you're relatively familiar with Linux, this is basically a Linux terminology, if you will. And the reason you need to mount a volume here is because we're running a database. So by default, when you shut down a Docker image, everything associated with this image goes away, including the disk space. Okay, so because we're running a database, we don't want to be doing that. So the way you get around this is you mount a what's called a local storage mechanism. So that's what this local storage means. PG data is referencing local storage in my inside my local Docker engine. It's literally something sitting in my own file system, and then I'm mounting that in the Docker image. So let's go ahead and run this Docker image, and I've done it, believe it or not, earlier in the morning. So I got up around 3 a.m. to get ready for you guys. So this is going to run very fast. Everything is already cached. As you can see, the database up and running, and it's listening on port 5432. So I have a database. Okay, so now I can go ahead and access this database. So I do have, again, I've cheated a little bit, and actually all of these steps are outlined in the instruction set of how to do all of this. So I'll just go through these, go through what I'm doing, and again, nothing too exciting, other than the Docker portion. You guys have probably done this a million times yourself. So basically, what I've done is I've set up Open Liberty on my own machine. I can go ahead and run this Open Liberty instance, and I will in just a moment. And other than that, I have sort of imported my little application into my IDE. This is a very simple Jakarta EE application. It's got all of the normal stuff in Jakarta EE, so JSF faces, dependency injection, persistence, bean validation, and so on. It is purely a Jakarta 8 application. It doesn't have any other dependencies. You'll see the sole dependency here is really just on Jakarta 8, and that's about it. There's really nothing much else. And some simple Maven configuration, and that's about it. So the application so much is not the point here. This could be any kind of application that uses the Jakarta EE platform and using Liberty. So I won't spend too much time there, but I will show you the application and show you how that looks like. So in order to do that, I'm just going to do a quick Maven clean and build just to make sure everything is set to go. So I'll go ahead and do that. Should be going relatively fast. Okay. Let me do a Maven build. All right, and there it goes. And as you can see here, what I got out of that is basically my WAR file. Okay, so my WAR file is ready to go now. I can now run this application. So I'll just right click it and say run on server. And that's going to start up my Liberty application, my Liberty runtime. I restarted my machine. Give me 1 second. Let me, what is happening here is that I already have not Liberty, but WebSphere Traditional running because I do some work in WebSphere Traditional. So I need to go shut down that WebSphere Traditional instance. So let me go ahead and do that. Just give me a moment. This is the wonder. This is the magic of live demos, right? Some things always gotta go not exactly as planned. So let me run this as admin. I'll shut it down. Then I'll be able to run the app server. Run Liberty. Waiting for stop status. So that is all shut down, and I'm going to just double check that I'm also still sharing. I am, yes. All right. Going back to here. So let me go back to the ID. Let's do that again. And this time it should start up. Okay, run on server. And there's Liberty up and running, and it should deploy just in a few moments. All right, so here's my application. It's very simple CRUD-based application. It has a JSF front end, but it also has a REST backend. So here's a REST backend there. I can do some simple CRUD operations. Let me go ahead and do that and show you the CRUD operations. And there you have it, right? Not a very exciting application. It's intended to be very, very simple. So let me shut that down. And actually, I don't need the IDE or the app server running in this way anymore. So I'm just gonna stop this and close my IDE. I won't need my IDE anymore. I don't need the database anymore locally running either. And I'll explain to you why in a moment. Okay, so hopefully this part is relatively straightforward, and you don't have much questions to go on that. So now let's move ahead and try to begin to put this application on the cloud using nothing much more than Kubernetes primitives. Okay, so here's the code to do that. So it's under the clustering subdirectory. As you can see, there's some prerequisites of how to do all that. And again, in the interest of time, I've done a lot of that ahead of time. So you will need Helm for certain parts of this demo. So you need to install Helm other than simply having installed Docker also. In this case, my database is running on the cloud. So I'm using Azure, but you could use using other clouds certainly. So here's the instructions on how to get that database up and running on the cloud. So I've done that ahead of time. So here's my so-called what's called resource group in Azure. This is my Azure portal. So this is the database that is up and running. As you can see, it says something like Azure database for Postgres. Okay, so that is all up and running. There's some activity going on in this as well, because I've been working on it, as I said earlier in the morning, just to make sure everything is okay. So there's the database. Here's the instructions on how to get all that set up. Main thing is it's the equivalent of what I did locally. So now I have a database on the cloud. So I also need a Kubernetes cluster, and again it takes about 15-20 minutes, sometimes as much as an hour for a cluster to deploy, depending on the size of your cluster. So again, I've done that ahead of time. So here's my cluster already up and running. It's an AKS cluster, and again, if you look at the activities here, there's some stuff that went on, right? So I basically have done some installation steps ahead of time to save ourselves some time. So it's not quite a fresh cluster, but almost a fresh cluster, but it is already set up for you. And again, here's the instructions on how to do that. So you will set up, once you have the cluster up and running, you need to access it. And typically you will access it using something called kubectl. It's basically a command line tool that you install locally, and that's how you interact with your remote Kubernetes cluster. So I've already set up all this up. Here's the instructions on how to do that. It's a simple command using the Azure command line, some command called AKS get credentials, and that will connect up to a remote AKS instance or Azure Kubernetes Service instance, and this is what I've done already. So I'll show you that is in fact what I have done. So I'll do kubectl get nodes. If I can type this morning, that would be helpful. So I just have one node, one machine, one logical machine, and that's good enough for this demo. Okay, so I'll also do get pods. So there are certain things that I already have set up on this machine, and I'll explain what these are, but I'll explain to you very simply what is going on. So I have two load balanced instances of an ingress controller. Think of this as an HTTP proxy running. And I also have the Open Liberty operator. Remember, I'll show you how to use operators with Kubernetes. So I do have the instance of the operator already up and running. But other than that, I do not have an application instance yet. Okay, so I also have, let's do services for a moment. And this is, and by the way, these are Kubernetes primitives, pods, nodes, services. These are all Kubernetes primitives. So I do have a few of these running. I don't know how well you can see this, but basically there's Kubernetes itself. Okay, and that's always accessible via 10.00.1. 10 dot is basically the subnet that this Kubernetes cluster is running on. I also have the ingress controller. Okay, that's a type of load balancer, and it has a internal IP and an external IP. Okay, and then there's also the admission controller that is a cluster IP. It only has an internal IP. So let me go ahead and access the load balancer that I already have up and running, and do this. That's cached. 100% sure. Okay, so it'll say not found because there's nothing to route to. Okay, it's just a load balancer that is up and running right now. As you can see, there is no pods or nodes running, so there's nothing to be found. So it'll tell you, hey, 404 not found. I don't know what you mean by root right at this moment. But what you can see is we do have a load balancer up and running, an ingress controller, Nginx ingress controller up and running. It just doesn't have anything to talk to. So these steps are already outlined. You do need an ingress controller in this particular application because it is a stateful application. You could use the Kubernetes primitives of a load balancer, of service type load balancer. The problem is those load balancers usually do not have very many capabilities. They simply do round robin load balancing, and that's about it. Because this is a stateful application, we want to actually use sticky sessions. So in order to use sticky sessions, you will need to look beyond simply Kubernetes primitive load balancers, and you will need to use an ingress controller. So in this case, I've actually installed the ingress controller, as you saw. So there's a few steps to do that. The steps are outlined here. Once you do that, you get an ingress controller up and running. As you saw, I'm using Nginx, but you don't have to use Nginx. There's also more powerful capabilities built into Azure. So you could be using something like called Azure Application Gateway, and that actually has native integration with Kubernetes as well. It's sort of built-in. It's a built-in controller that you don't actually see up and running in the Kubernetes space. But I'll leave that to you as an exercise. So main thing is that there is a controller up and running that I can now reference. I can deploy. The next step is to deploy the application to Kubernetes. So in order to do that, the first step is to build a WAR file, which as you saw, I've already done. So let me just manipulate this in the file system in the interest of time. So I'll go into Jakarta EE Kubernetes. Here's my Jakarta EE directory. Here's my app. In the target directory, I have a WAR file. Let me copy that. Okay. I'm going to go into the clustering directory and just simply paste this here. Yeah, replace. So this is a fresh WAR that I just deployed. So now we're going to go ahead and the first thing we need to do is build our Docker image. Okay, before we can use Kubernetes, we need to use Docker. So I'm going to show you how to do all that. First thing I'm going to do is just execute the command for you, and then I'll explain the pieces behind the scenes as to what exactly is going on. All right, so I'm going to run the Docker image for us. So here's the syntax. Docker build means build a Docker image. You saw Docker run before. This is Docker build. -t is specifying the full name of the image. So because I'm ultimately, in order for me to use this in Kubernetes, use this image in Kubernetes, I will need to upload it into a registry of some kind. Okay, so with Azure, you can use Azure Container Registry, but in this case, I actually chose to use just Docker Hub. Okay, it's you can definitely use Docker Hub with Azure. In fact, you can use any registry with Azure. So I do need to give it a name that is sensible in my registry. So I need to give it my account name, which is REZA RAHMAN, and the name of the Docker image, which is Jakarta EE Cafe, and :v1 is the version. You don't have to specify the version, but in this case, I am going to, because I'm showing you different flavors of the application. So I'll use a versioning number to sort of decipher that. And dot refers to the fact that there is a Docker file right in this same directory. So I'm asking it to take a look at the Docker file and build a Docker image. I'll show you the Docker file and the pieces that are going into the Docker file also. So let me run this real quick. And again, this will be quick because I've already cached everything. So let me show you what is going on within this directory. So first and foremost, you have the war file. Okay, so let's start with the Docker file and make the assumption that yes, we do have a war file already. And let me increase the font a little bit so you can see this a bit more clearly. Do let me know if you cannot see it. I hope the font is okay. Let me just check. Okay. All right. Hopefully you guys can see it. I'm going to check on you. If you cannot see it and the font is too small, please do let me know, and I'll try to fix it going forward. Okay, so a Docker file is really nothing much more than describing what a sort of an operating system image should look like. Okay, so it looks very similar to Unix syntax for the most part, or Linux syntax for the most part. From Liberty is basically saying use the base image, so you're always building on images, other images in Docker. In this case, I'm simply saying, hey, give me the default image for WebSphere Liberty, and that will basically include everything to include run a Jakarta EE application. You can start with something called a Liberty kernel, and in fact, that is actually a best practice. I'm not doing it in this demo, but it's actually better to start with the Liberty kernel, and that is very, very core runtime of what it requires to run Liberty. And then there is a script in the Liberty runtime called configure.sh. And what that does is that it basically automatically determines what you need on top of the core, what APIs you are using, your application is using, and builds a very highly optimized Docker image. But that takes a little bit of time. So in this live demo, I won't have time to do that. So I'm just doing it the easy way, which is just get the base Liberty image, and already has everything that I need in it. And then I'm connecting to the database, so I need a database driver. Okay, so I copy that over to the shared resources directory for Docker. Then I'm adding the server.xml, and I'll show you the server.xml and what the configuration there is. And then finally, I add the war file as a layer, and that's it. That's all I really need in order for this Docker image to work. Now I do have a custom server.xml, and there's actually a few interesting things there. And by the way, let me check to see if everyone is okay with the font size. I think so. All right. So here are the features I'm using. I'm using Java E8. I'm using session database because what I'm doing here is actually assuming this is a stateful application, and I'm storing my session state in the database. Okay, so this is actually a clustered application, and I'm also going to make use of the admin center in Liberty. Okay, just to show you one way of doing application server administration in the Kubernetes world. So other than that, there's not actually a whole lot of stuff going on. I've specified a username and password that I'm going to use for the console. There is HTTP endpoint defined. Here's where I'm saying, hey, please store my session in the database. And there's simply some information about connecting to the database that is variableized. Okay, so I'm actually referencing environment variables, and I'm going to actually place these in. I'm going to specify these environment variables not here, but actually in my Kubernetes deployment. So when I do the Kubernetes deployment, I will specify these values there. So other than that, not a lot interesting going on in the server.xml. That's basically the sum of the session server.xml. So now that I've built the image, I'm going to go ahead and publish this Docker image, or push this Docker image into my public repo. So I'll go ahead and do that. So this is a syntax to do that. All right. So again, just basically the name that I built the image with, and simply Docker push. So I'll go ahead and do the push here. And again, hopefully this will just go through pretty quickly because I've done this a little bit ahead of time. And if it doesn't, then it's gonna kill time in my demo. But hopefully not. Yeah, it's all cached. It's up there now. So now if I go to my Docker Hub, I do that. So let me sign in. And if you look at my repos, you'll see that this Jakarta EE Cafe, the several tags here, the V1 is the one that we're using right now. And as you can see, it was updated just a few seconds ago. Okay, so I do have now the image available now in my public repo. Okay, so going back to where I was, the next step is to actually do the Kubernetes deployment. Okay, so let's go ahead and do that. And then when I do the Kubernetes deployment, I'll show you the deployment descriptor. So you'll be able to see what I'm actually deploying. Okay, so let me first just do the deployment. So you do that via kube control create and then specifying the deployment descriptor. And it is all created. I'm just going to confirm that it is created. Then I'll show you what all is going on. So, but I just need to confirm that everything was up and running. Okay, yep, it is. So as you can see, now it has changed a little bit, right? So before we had the two ingress controllers and the Open Liberty operator running, and now we have these two other apps running here as well. So they are up and running and ready. And basically, the way I've configured this, I'll show you the configuration in a moment. The Nginx controller is actually looking at those pods. Okay, so if I just reload this now, it will no longer say 404. It'll actually tell you, hey, I'm able to detect an Open Liberty instance, and we can take a look at our application up and running on the cloud also. Okay, so here's the same application. Now it's running on Kubernetes. So let me go back now and show you the deployment descriptor and show you what exactly has happened. Okay, so here's the deployment descriptor. All right. So there's several parts of this deployment descriptor. The first and most important part is the deployment itself. So this is where I'm describing what to deploy. I'm giving it some metadata, but the name of the application is Jakarta EE Cafe. There are two copies of this. You saw that there were two pods running. So this is where that's coming from. I'm saying, please install two copies of Liberty in the application. Here's some selectors and the like. Most of this is boilerplate. The most important part here is the image name. And I've actually specified my Docker Hub account. If you look at my local one, let me go ahead and do that actually. So let me do cat Docker file. Okay, sorry, that's not what I intend to do. Cat jakartacafe.yaml. And as you can see, if I scroll up a bit here, farther up, sorry. Okay, you can see that I've specified the name of the image that I have in my in my Docker Hub repo. So next, I'm going to deploy. I do need to deploy a service in order for pods to speak, if you will, to talk to communicate. You need to attach it to a service. So in this case, I'm attaching it to a cluster IP. So the two pods will basically be accessible within the cluster. Okay, so when I do that, I need to say, hey, this is going to be talking on port 80 and port 443. By default, Liberty talks on port 90, 80, and 443. So I'm just revamping those ports to things that are available by default in the Nginx controller, the default HTTP port and the default HTTPS port. And finally, I do need to attach the ingress controller. Okay, so I attach it by name. So as you can see, this is the name that I'm attaching it with. And those are again the port mappings. Okay, so I'm saying, take the Jakarta EE Cafe application. So this is how the Nginx controller is actually detecting when something is running, is via this name. And again, do those simple port mappings. And here's where the main thing is, I wanted to use the Nginx cookies, right? So in this case, I'm using session affinity basically. And I still, oh no, I still have it. So let me show you the first simple way where you can use that the admin or the app server's capabilities, and we'll just use the admin center capability built into Liberty as a simple way of sort of monitoring your application. If I remember this correctly. Okay. So if you hit Explore here, you'll be able to see some information about the application. It is running. Here's some monitoring information about this app server. We just started, so there's not going to be a lot of information, but some. Okay, you can see a little bit of information about CPU usage, active JVM count, and so on. But this is only for a particular pod. Okay, so the pod that I just logged on onto, that's about it. So this tells you a little bit about how app server load balancing and clustering works in a Kubernetes-based environment. So before I forget, I'm going to go ahead and remove this deployment. So in order to do that, I just need to use the deployment descriptor and say delete. Okay. I did not manage to copy that correctly. So let me go back there again. Say copy, paste. Okay, and this is simply kubectl delete and then the deployment descriptor. So deleting that, and let me just make sure that by doing a get pods, and I need to do a watch in this case. Yep, as you can see, it says terminating. Okay, so it is going to say it is going to go away very, very soon. Let me try that once again. Control C. I think it may be gone by now. Let's take a look. Yep, they're both gone. So back to just the controller, the Nginx controllers, and the Liberty operator, which I haven't used quite yet. Okay, so this tells you a little bit about how the Jakarta EE applications work in terms of load balancing. So the load balancing is no longer controlled by the app server; it's controlled by Kubernetes. Okay, so using the Kubernetes primitives, the deployment is controlled by Kubernetes. You are ultimately deploying a WAR file, but it's very different from your traditional, deployment mechanisms. You saw how the clustering works in a Kubernetes-based environment. So all of the basically the net lesson here is that all of the capabilities that you normally would have in the app server world, on the on-premise world, more or less translates well to the Kubernetes world. I only have what 5 minutes or so. I hope I'll try to go through the operator demo really quickly for you guys. Okay, but let me know if you have any questions in the meanwhile. Let me check. Okay, there's a few questions. Okay, so let me answer the questions for you since we don't have a tremendous amount of time. And in fact, I think I'm going to skip over, since I'm actually out of time, I'm going to skip over the operator demo. I'll just show you the code. Okay, is Java EE and Jakarta EE plus MicroProfile, this whole ecosystem, ready for Kubernetes? Yeah, it's very, very ready. We have a number of people that have been using Jakarta EE and Java EE with Kubernetes and Docker for a very, very long time. It's very, very mature. I'd say probably Jakarta EE is more ready than a lot of other platforms. So you'll see that in a moment when I show you the operators. Really, the Java EE ecosystem is at the very bleeding edge of at least Docker and Kubernetes support for sure. Okay, can Java EE and Kubernetes replace Java app and app containers? Yes, absolutely. Yeah, as you can see, you can use the primitives to quite easily, basically integrate the Java EE way of doing things with the Kubernetes way of doing things. We're using Docker Swarm. What's the difference between what about autoscaling in Kubernetes, especially Jakarta EE? Docker Swarm is basically yet another orchestration platform. It's not very well supported. If you look at Amazon or Azure or Google, really they're using Kubernetes as the orchestration platform. Docker Swarm has sort of fallen out of favor as a certainly as an orchestration platform. Some people still use it as sort of for on-premise type things. It's very rare that I see Docker Swarm in use at all, at least from the public cloud. But you can think of it as yet another way of doing container orchestration. Okay, do you know that Windows containers also supported in Kubernetes? Yes, Windows containers are supported in Kubernetes. They're a little less mature than most Linux containers. I believe even on Azure, we actually have more Linux containers running than Windows containers, but yes, you can run Windows on Kubernetes also. Where can you read more about Jakarta EE? Best place to do that is the official Jakarta EE website and tutorial. So you'll see all of that by just typing in jakarta.ee, and then you can investigate more about Jakarta EE fairly easily. Okay, and we're using Docker Swarm. Yeah, so if you're using Docker Swarm, honestly, consider using Kubernetes. It's especially in the public cloud. That's what you're going to probably need to use. You definitely use auto scaling. So if you go back here, there's actually an example of where I was going to show you auto scaling, but there's just not enough time to do that. So you can either auto scale by demand, and you can configure Kubernetes to do that, or a very simple way is just doing it manually. Okay, so for example, if I wanted to bump up the replicas from 2 to 3, I just need to specify the deployment replicas equals 3, and that'll at runtime decrement and increment my my number of pods. So auto scaling is definitely very easy to do on Kubernetes. And as I say, you can also configure it to do that automatically. So you don't have to do that manually necessarily. All right, so I am actually pretty much out of time. Let me show you the operator's way of doing things, okay? So the key differentiator, a lot of it is very, very similar. You do need to install the operator. So this is the steps on how to install the operator. It's relatively simple. As you can see, it's already up and running. The rest of the steps are very similar. You need to build a WAR file. You need to build a corresponding Docker image. You need to publish that Docker image. And then finally, you need to create the deployment descriptor. So I'll show you the deployment descriptor. That's where the secret sauce mostly is. Okay, so this you see is a lot simpler than using Kubernetes primitives. That's one. And the reason for that is we're referencing the operator. So the kind is not a type of deployment or service, but the kind is actually a type of open liberty application. And that allows for a much more compact syntax. Okay, so you still specify the name, you specify the number of replicas, you specify the image name. I'm still specifying the environment variables. But everything else is very compact. So everything is encapsulated by the operator, and actually the operator is what is going to do the deployment. So in this case, the operator is much more aware of the cluster and can maintain internal cluster state by itself. Okay, as opposed to the cluster state being maintained by Kubernetes, and also you can do things like distributed logging and tracing using the operator as well, because the operator is in control of the cluster in this case, and that's the central point of control, if you will. So yeah, that's about it in terms of the operator. I won't be able to show you in action, but it should be relatively straightforward to use. So I hope this was enough of sort of a feel for what's in the what's in the workshop, so that you can take a look at it yourself. It's supposed to be self-service. Okay, you ought to be able to go through this and sort of observe what the best practices are and various trade-offs are, the ones that I talked about. There's of course many others, but these are some of the key ones with regards to Jakarta EE and MicroProfile. And if you have any other questions, you can always reach out to me later. My contact information is on the on the chat. So going back to my chat, you'll see that there at the very top. Otherwise, just go to my public repo, and it's available there also. So that's all the time that I have today. I really appreciate it. It's like, when you're trying to take an 8-hour workshop and trying to condense it down to 40 minutes, it's always a tough thing. But thank you for your time. I appreciate it. I hope you got enough of it. And again, if you have questions or concerns, you can reach out to me later.
Thanks, Reza. If you have any questions, you can contact Reza using his contact details. Thank you for being here with us. Thank you, Reza.
For sure.